Dominic, it's a pleasure to finally meet you here at Paris Blockchain Week. How did you enjoy the event this far?
It's been fun. It's an amazing event, amazing venue. Last night, got to see the Mona Lisa in the Louvre, which is pretty cool. And there was a lot of energy here.
I saw the picture on Twitter, very nice picture with the Mona Lisa. When I went to the Mona Lisa, it was a lot more crowded than it was when you were.
That's true. Actually, I realized what a privilege it was this morning, because you come in and there's like this line, a queue that looks like about a kilometer long.
Yeah, it's crazy.
So, yeah.
It is insane. So I want to ask you, for the people that are new to the blockchain space and who have not heard about Internet Computer Protocol, what is the role that ICP plays in the blockchain world?
So it's a third generation blockchain, and the first layer was like blockchains that just host a cryptocurrency ledger, like Bitcoin. Obviously, Bitcoin was the first, and you had like competitors like Litecoin, silver to Bitcoin's gold, some other ones like Feathercoin that disappeared. Then you get the second lane, which is traditional blockchains that host smart contracts. That was pioneered by Ethereum. Now you've got all kinds of competitors like Solana and Avalanche and Near and all these layer 2s and things like that. And they're probably more successful at taking a chunk out of Ethereum's lead than some of the competitors of Bitcoin were. And then you got the third lane, which is blockchain that really plays the role in a way of cloud, where you build using smart contracts, where you can build something like a social network entirely for smart contracts. And the big change is that you can't even store a phone photo on Solana. Like, people talk about how fast and scalable it is. Well, that really applies to DeFi transactions. And you can store tokens on Solana, and you can put some DeFi logic there. You can put some meme coins on Solana. But when you see the user experience or media or heavy-duty compute, that's not happening on Solana. It's happening typically on Amazon Web Services. The change with third-generation blockchain is that everything runs on-chain, and you have some changes like reverse gas, but also third-generation blockchain has to be infinitely scalable, extremely efficient, and so on. So the smart contracts will actually process HTTP and serve user experiences directly into your web browser. So as a user, you can directly interact with code on the blockchain that's autonomous, controlled by a DAO or something like that. And so you can build something like a social network on the blockchain, put it under the control of a DAO, which means it's autonomous and updated transparently, and put the user community in control, make them owners, which of course is kind of the promise of Web3. And that's what third generation blockchain does. And even recently, we've been able to demonstrate AI models running on the blockchain and smart contracts. I did a demo a few weeks ago of a neural network doing image classification running as a smart contract. But we're pushing, we're working very hard at the Dfinity Foundation to improve the efficiency and remove some limits on the internet computer, so that hopefully within a few months we'll see it hosting large language models.
On-chain seems to be the running narrative for this bull run, and since ICP is one of the leaders, if not the leader, in on-chain, what do you think are the benefits of hosting everything on-chain as opposed to using legacy solutions like Amazon Web Services and Google Cloud and so on?
Yeah, well, look, firstly, blockchain remains a place or an industry that's very much run by narratives and memes. And, there's a lot of people, for example, talking about the blockchain for AI or the token for AI. And I think, people out there get confused. That doesn't mean they're actually running AI as smart contracts, right? And similarly, being on-chain is a new kind of thing. But as far as we're aware, at least today, internet computer smart contracts are the only ones that, for example, benefit from the reverse gas model, so they can pay for their own computation, that can process HTTP to serve the user experience. We're not aware yet of any other third-generation blockchains or blockchains that can really fairly lay claim to providing that kind of functionality. But yeah, look, on-chain is incredibly important. I'll give you some examples. First of all, let's look at DeFi. There's a regulatory dimension, right? So MiCA, which is the Markets and Crypto Assets Regulation in Europe, means that if you build a system like Uniswap out of Ethereum smart contracts, which are decentralized, but you then go and build a centralized user experience, for example on Amazon Web Services, then because you built a large part of the system is centralized, you'll be required to do KYC. So one way to solve that is you can build the user experience on the internet computer. You can put it under the control of a DAO. There's a special kind of DAO on the internet computer called a service nervous system, so that the user experience is completely decentralized. Actually, there's cross-chain functionality, so you can even decentralize control of your Ethereum smart contracts if you need to be able to update them that way too. And then you basically go full stack decentralization. You've got a decentralized user experience running, under the control of a DAO. And if you want, you can, if you don't already have mechanisms on Ethereum, you can use the internet computer for updating those smart contracts too. And now you've got end-to-end decentralization, and that's a big advance. And it might help you with respect to regulations like MiCA. But there's also other reasons too, of course. If you look at most of the hacks in the, in the blockchain space, they tend to fall in two camps. One is the hackers are exploiting things like reentrancy bugs in Ethereum smart contracts, and just exploiting the logic because of, EVM's quite old virtual machine now, and the design of the system does lend itself to these kind of attacks, so you gotta be very careful and audit your Ethereum code, but some mistakes slip through. So that's one bucket of hacks. The other bigger one though is that the hackers just go after centralized infrastructure, whether that's bridges or whether they take control of the user experience that's running on traditional IT. So for example, at Dfinity, for example, a huge Web3 game. In reality, of course, most of that was running on Amazon Web Services or some other centralized infrastructure, and there was a hot wallet involved. And so it's, just the same as, hackers will hack into a centralized exchange to get hold of the hot wallet, they'll hack into Dfinity or a bridge. So the advantage is if you go fully on-chain, smart contracts are tamper-proof. You don't need to protect them with firewalls and intrusion detection and anti-malware and security teams. So if you look at the internet computer, for instance, it's hosting social networks. And some of them, like, OpenChat, they do chat and stuff like that, and as well as being like a place for communities to form. It's all fully on-chain. And actually, your OpenChat account is also a crypto wallet. And people send crypto via chat messages on OpenChat. So that's been running for like 3 years now, and it's got a large community. There's a bunch of crypto inside. It's got no firewall protection, no anti-malware, etc. Right? No, not even a security team.
And this far, no hacks.
And this far, it's important to say. But if the purpose of blockchain is to provide a platform that runs on secure mathematics, hackers cannot make 2 + 2 = 5, right? So. And this far, all of those kind of services on the internet computer that have crypto inside have proven hack-proof. So that's a huge advantage, number one. And number two, if you build your, social network, social media, metaverse game, DeFi, whatever it is, fully on-chain, you can put it under the control of an internet community through a DAO. And that's what Web3 is all about. That you can, enlist the community of something like OpenChat as part of a virtual team that will, go out there and help promote the Web3 service and create content maybe in return for token incentives and so on. And Web3 is all about giving ownership to, the end user. And, the ultimate destination of that is things like social networks that run under the full transparent control of community DAOs. And that's what you can do if you go fully on-chain. And that's what's happening on the internet computer today.
I agree. And we know that on-chain is going to be the future because every other ecosystem out there, every other blockchain claims and uses the fact that, you can do this on-chain. And most recently, we've seen Solana celebrating, the whole ecosystem got together and celebrated that they managed to send the first email via the Solana blockchain. And as you mentioned, OpenChat, we have been sending messages and photos and transactions, everything happening on-chain for the past 3 years. So have any other ecosystems reached out to Dfinity to start using the ICP infrastructure and actually get on-chain?
Well, look, so first of all, remember that, there's a lot of smoke and mirrors in blockchain, right? There's a lot of decentralization theater. So I haven't looked into the Solana on-chain demo, but look, what I can tell you is Solana can't store a phone photo, right?
Yeah.
So how on earth is it storing emails which might have PDF attachments and things like that? Doesn't make any sense. What they're probably doing is storing the hash of an email on chain or something like that. I'd imagine, right? Which is something very different to running, a communication system on chain. So, you also hear a lot about blockchains, running AI, right? Like, I'll go on a limb here and tell you that it's all nonsense, right? There's not a single blockchain in existence I'm aware of other than the internet computers running AI smart contracts. But, people do this kind of like, somebody got in a panel with Jensen Huang, got touched by Jensen Huang from NVIDIA, and everyone's like, near to the moon, it's AI, right? But, near's not running AI smart contracts. Solana has this thing about AI. Again, they can't even store a phone photo on chain. I mean, you need to be able to store, billions of neuron weights if you're going to, hold them in memory, smart contract memory, if you want to run an AI model as a smart contract. So obviously, if you can't store a phone photo, then you can't do that, right? It's like some kind of connector to ChatGPT. So I think that's, it's challenging for people out there to see through all this noise and this hype. But, I can tell people categorically today there is only one third generation blockchain in existence, and it's the internet computer. Today it's running neural networks and smart contracts. In the future, we're working very hard to improve the network and remove some of the limits so people can actually run large language models as smart contracts. It's not possible today because, without getting into too many technical details, internet computer is a WebAssembly system, right? It's a WebAssembly virtual machine. We're using a 32-bit virtual machine, and that it means you can only 32 bits means you can only have 4 gig of memory. Mm-hmm. It's like going back to Windows 95 or something, right? And that limits you to about 2 billion parameters. Large language models need about 6 or 7, right? But we're about to go to 64-bit WASM, which means we can raise the main memory limit for smart contracts to something like 15 gig, and then it'll be possible. And we're also working on the efficiency and introducing. Recently, we made a decision to propose that SIMD instructions be introduced into the virtual machine environment, which will really, improve efficiency 5x, etc. But it's a very technical job, and the technology is necessarily pretty complicated. We have hundreds of PhDs and engineers working on this, and the progress will be pretty quick. But at the moment, of course, it's not possible, I think, to really run a large language model on blockchain. But hopefully, we'll be so in a few months.
Right. So those are the reasons why on-chain AI on the Internet Computer Protocol has been such a big breakthrough. But a lot of people have been wondering, why is it so more beneficial to have AI on-chain as opposed to having it on AWS? Okay.
So, here's a statement. I'll go on a limb again. I'll tell you, look, it's going to be a few years, but in the end, the vast majority of AI models are run as smart contracts. And it's a really simple reason. AI has a particular demand for security. So, first of all, if you run an AI model on traditional IT infrastructure, that traditional IT infrastructure isn't secure. And you can use all the firewalls in the world, all the intrusion detection in the world, all the anti-malware in the world. As we can see, it gets hacked all the time. Oftentimes, you're going to want to connect AI to all your most sensitive and confidential information. Like, say, for example, you run like an AI for your startup or your government department or whatever it is. And it's like an AI which will schedule meetings, and you can ask it, like, who's running that team? Is anybody blocked? Has anyone any ideas for PR? This AI probably is like streaming all of your org's, chat messages, emails, calendar, if it's a technical org, Jira and GitHub, et cetera, right? So if the hacker can, get onto the IT infrastructure running the AI, he's going to get all of the most confidential information and sensitive information in one place. Secondly, we're going to come to depend on AI, right? So if you think about like 20 years ago, before SatNav, if you're going to go from, somewhere in a big city or out from the city into the countryside, you start off by looking at a paper map, and you would memorize the route, and you keep that route in your head, and you make all the right turns, and you get there. For most people, I used to do that for years, but if you asked me to do it now, I probably couldn't, because I've been using SatNav for 20 years, and I've of course come to depend on it, right? I've lost the skill. When people and organizations introduce AI, they're going to lose a lot of skills, and they're going to come to depend on the AI, and they're going to use their brains for something else, right? And that means if you're, for example, using the AI as a nexus of information in your organization and coordination, you're going to come to depend on it. And if that AI stops working, it's going to be very bad. because everyone's depending on it. And a bit like if you took sat nav away today. So it's very important that AI, is highly resilient. One of the advantages of smart contracts is they're unstoppable. You don't get like one error that makes the whole thing crash. So it's unstoppable. So that's another reason you got security, you got resilience. It's unstoppable. But also you can make it autonomous. So I've been talking about, like, imagine you can get an internet computer AI smart contract that audits the code of Solidity contracts on Ethereum. So today you got an Ether scan. You can see the Solidity code for a smart contract, right? And let's say you want to interact with a smart contract. The thing is, most people don't read Solidity. So they're not, and even if you're a Solidity dev, you don't want to audit someone else's smart contract. But if you've got an internet computer smart contract, with a large language model inside that can validate Ethereum smart contracts and check there's no reentrancy bugs, backdoors that could lead to a rug pull, malicious code that could make or malware that could make the smart contract interact maliciously with other smart contracts that you have accounts with. Well, now that AI smart contract can download the root hash of the Ethereum smart contract, get the code from GitHub, read the Solidity, and issue a certificate, like a kite mark that says this smart contract has been audited by AI and it didn't find any problems. And you could put that on Etherscan, and that will give people a much higher level of assurance that oh look, here's the Solidity code. I don't read it, or I haven't got time to read it. But that's okay. The AI, which anyway is going to be probably better than the best smart contract auditor, has gone through it and made sure it's safe to use. Now, the reason this should run the auditor should run as a smart contract is otherwise you have to trust the human being that controls it. That's autonomy. So, smart contracts can be autonomous. So in this case, the smart contract doesn't have a human controller, and we know that if this Ethereum smart contract is certified, that's because the logic of the AI says that it's safe, not because some controller of the AI, because it's running on traditional IT, right, has issued the certification themselves, and that's autonomy. So you've got these three magic properties. Smart contracts are tamper-proof, gives you security, they're unstoppable, gives you resilience, and they're autonomous, and that removes intermediaries, which of course is the thing that Satoshi started with. Like, if you want to trust something, there better not be an intermediary. And so if you want to trust the smart contract auditing, there better not be a human intermediary that could have done that, credit the certificate. You better be sure that the AI is autonomous. So, those are the things you can only get if you run you run the AI as a smart contract. And that's why I think in the long run, people are going to need AI that's secure. People are going to need AI that is resilient. And of course, within the Web3 space, we're going to need autonomous AIs without intermediaries. And that's why I think in the long run, the majority of smart contracts will run as the majority of AIs will run as smart contracts.
Yeah, absolutely. And I remember one of the slides in one of your presentations in 2023, if I'm not mistaken, cybercrime or cybersecurity accounted for a huge number, something like $1.8 billion only in that year alone. So hosting stuff on the Internet Computer Protocol would absolutely cut this a huge number.
Sure. So actually, I used to have my numbers wrong. I think it was last year or this year we spent $1.8 trillion on IT personnel.
Okay.
And actually, that's a separate thing. If you look at IT personnel, they spend 95% of their time chasing complexity. Mm-hmm. And we believe building on third generation blockchain greatly simplifies R&D and will make IT personnel much more productive. So whether that's to save costs or have them, build better systems, it's up to you. That's one thing. People spend $1 trillion a year on software licenses. If you build on blockchain, like third generation blockchain, you don't need databases, for example, right? The data sticks to the code on third generation blockchain. Then there's the security piece, right? We spend about $200 billion a year on cybersecurity. But that doesn't tell the whole story. The cost of cybercrime next year, 2025, is predicted to pass $10 trillion. 10 trillion. That's like it's going to be more than 35% of the United States GDP. So cybercrime has become an issue, for the world on a par with war and climate change. And that $10 trillion would be far better re-injected into the economy, or spent helping the developing world modernize, right? So, traditional IT, there is no real solution to the problem of cybercrime and cyber breaches and so on. The fact is, you start off with the operating system is not secure. and you try and configure it to make it secure. You put databases and platform software onto it, web servers and everything else, and you try and configure that so it's secure. But the whole thing, and then you put it on the cloud, which isn't really secure. Then you should orchestrate it with Kubernetes, which isn't secure. But then you're like, shoot, this whole thing I built, this whole Rube Goldberg machine that I built with traditional IT, it's a completely, insecure mess. So what do? Well, you try and protect it with cybersecurity. You try and put a firewall around it. You have intrusion logging detection to see if someone's got past the firewall. You have anti-malware to see if any of the software updates you're making have a virus inside or something, or ransomware inside. The trouble is, it's completely fallible. If you start with something that's fundamentally insecure and you try and protect it with cybersecurity, inevitably people are going to get past the cybersecurity and then it all goes horribly wrong. And we're seeing this all the time. So, we believe that building on third generation blockchain provides a complete solution because you don't even need cybersecurity. It's a bit like OpenChat, it's this kind of social network built on third generation blockchain that has crypto inside. It doesn't have any cybersecurity protections. It doesn't even have a cybersecurity team. It's never been hacked. So imagine that Web3 that demonstration of a Web3 architecture within the government and enterprise space. Actually, we've got a project we're supporting called Utopia, which repurposes ICP technology for the government and big corporate domains because they can't build on a public network. But that technology we use to create a new kind of private sovereign cloud, the serverless, where you build with what's essentially smart contract technology, and now you don't have to worry about getting hacked anymore. You don't have to worry about. You also get resilience, much better resilience, because of course, smart contracts are unstoppable. Albeit they won't have so many nodes and they'll be running it themselves and so on. But, the technology has broader applicability outside of Web3, and that's what we're going to see happen. And one of the biggest drivers of all this, of course, will be just the ever-increasing costs of cybercrime and the ever greater difficulty of using cybersecurity to protect systems, and which, by the way, is about to get worse with AI. AI can support hackers, and AI can even write malware. AI can even do hacks itself. So cybersecurity challenge is about to become, in the next 5 years, much, much more difficult.
Right, so this should answer the question of people that wonder why does on-chain really matter. So right now they're trying to build on a foundation that is flawed and it will eventually go down. And instead they could use an evolved solution, which is building on the Internet Computer Protocol with so many benefits that you just mentioned.
Totally, and look, a lot of people have come into the Web3 space more recently. People like me have been around for a lot longer. And if you like, my schooling in thinking with respect to Web3 and decentralization really came from Satoshi's early work, right? And the fundamental level, it's all about removing intermediaries. So, and blockchains do this by having multiple people verify computation. One analogy I actually got from a guy called Nick Szabo, which I kind of like, is about the ticket ripper and the ticket seller. So even if you go back to the earliest cinemas, right, you would find that as you come in, there's a ticket office where you buy your ticket, and then you go through the door and there's somebody who rips the ticket, right? There's a ticket seller and the ticket ripper. Why do you have two people? Why is the cinema paying, even a small cinema, why is it paying for extra stuff? Well, the answer is that if you only have one person at the ticket office, a group of their friends can come along and they can issue them or just, let them go through. You don't even need a ticket, right? But because you've got a ticket seller and a ticket ripper, in order for that, for the employee to defraud the cinema kind of thing, they'd have to collude with the ticket, the ticket seller. So that's why you have a ticket seller and a ticket ripper. And of course, with a blockchain, you do that on a much bigger scale. You have far more than two people validating things. So once you've done that, right, you don't have to trust the result. And then you can remove intermediaries. And an intermediary is something like a bank, right, that can close your account or steal your money. Mm-hmm. But an intermediary, by the way, is Amazon Web Services, right? And, they even shut down that thing that was right-wing, what was it, Parler or something like that before the election where Trump lost. I'm not saying I'm a Trump supporter, but, I'm certainly against social media services running on cloud being shut down for political purposes. And also the developers are intermediaries, right? Like the developers, if you're interacting with a Web3 service that's running on Amazon Web Services, the developer's got the username and password, right? And that means they can log in, they can arbitrarily change your content, They can change the user experience. They can inject malicious code that will steal your crypto. All kinds of bad stuff. So that's why intermediaries have to be removed. And the way to remove intermediaries is to run 100% on blockchain. Yeah, so, Web3 is all about running on blockchain, and really nobody should be building systems on Amazon Web Services anymore. That's why we got third generation blockchain, which allows you to achieve what we call full stack decentralization, where everything's on the chain, there's no intermediary. If you've granted control over your systems, your service to a DAO, you removed all the back doors, it's completely secure, the community's in control. That's true Web3 for us.
You mentioned Utopia, and that is going to help big companies and institutions start developing on the Internet Computer Protocol. Can you give us some names of institutions or big companies that are planning to build, if not already building, on the Internet Computer?
Well, I mean, so first of all, Internet Computer is really a Web3 platform. I think over time you'll see more and more companies using it. But if you look at governments and corporations, generally speaking, they won't build in a public network. Now, in the case of the Internet Computer, it's not like a normal blockchain. It does provide a level of privacy for the contents of smart contracts and the computations they perform. And that's because the protocol controls, which nodes that the smart contracts are replicated on through the subnet architecture. And there's too much computation for you to download it all. You just instead interact with the smart contracts. Having said that, though, if you're interacting with smart contracts on the Internet Computer network, the blockchain behind the scenes is, replicating the computation and data over these node machines, and uses a system called deterministic decentralization. So every node machine is owned and operated by a different node provider, typically in different data centers, in different geographies, in different jurisdictions, etc. Right? But nonetheless, it is being, the data and computation is being replicated. So if you're a big corporation, you're like, well, or a government, my data's on the public network. That means that all these different companies have got a copy of it, right? So, in Web3 it doesn't matter. In the future it will matter less because the protocol will provide even stronger, privacy protections. But for now, it's like, public networks are ready for Web3 or shared systems. So, there was a system called the voluntary recycling credits VRC exchange, and that was built in the Internet Computer, and we announced it. This PSC is huge environmental conference, mainly for government recently, and that was like Roland Berger, big business management consultancy, BR, which is a huge 13,000 person company in UAE that does waste management stuff. ISWA, like the International Solid Waste Association, someone from the Brazilian government, and so on. And I believe after that demo, there was inbound for 12, 13 different governments wanting to participate. So that's like a consortium system, though, right? So there was like an exchange, and it's really worth looking at the demo or even getting access to it, to check it out, what's possible to build. It runs on the Internet Computer, built entirely from smart contracts that even serve the user experience. And once that's all finalized, actually it will be like the service nervous system DAO that currently would control some of the social, typically has tens of thousands of people controlling internet service currently, right? Now, same technology will be used for like a consortium of big business and governments, where you might have 100 people, organizations participating and holding the governance tokens, and they together will control the logic of the VLC exchange, which is really to people, you heard about carbon credits. It does the same thing for recycling. So someone is recycling plastics in Brazil, for example, they can mint some recycling credits, and then some company like Coca-Cola, they inside those Coca-Cola cans there's a plastic sheath, and they want to say that they've recycled it all. So what they do is they buy recycling credits, right? But the beautiful thing is that there's no gatekeeper, right? This is like an open exchange. There's no owner. There's no one who controls it. It's controlled by a DAO, and the people who have governance tokens are people in the field of recycling.
Which are some of the ICP projects that you think should get more recognition? What are the projects that you are looking at?
Man, the trouble is, right, I got to be really careful because, I'm so busy, and in so many ways. Oftentimes, I'm totally unaware of amazing projects. And so what happens is I tend to go back to projects that I know because they were early or I'm linked to them in some way. I mean, that's why I always talk about OpenChat. It's one of the first social networks on the internet computer. And really it's unfair because there's a lot of people building stuff. I'll give you an example. One that doesn't even use, it's DAO controlled, but they create their own DAO framework, is Tagger. Tagger's amazing, and that's really innovative, and they're exploring like how you can completely redefine social media using Web3, and some really interesting stuff going on there. But again, that's another project I've looked at because they actually had a problem with their DAO. They couldn't update Tagger anymore, so they got the network nervous system, which is the main DAO that runs inside computer to
save the DAO.
To save it, yeah. So again, like I'm familiar with it, and I know there's lots and lots of other projects. There was actually a project I tweeted I never even heard of before, which is using the internet computer to verify zero knowledge proofs, and then pushing using chain fusion, which is an internet computer technology, to push a call to a smart contract saying this zero knowledge proof has been validated. I mean, there's so much stuff going on, and so I wouldn't want to call out any individual project having just done it. One I'm excited about, but again, it's not fair because I know the guy behind it, is Dragons. And Dragons, I can tell you, is definitely a dark horse. I don't know if they'll ever finish it, that's the danger, but there's actually a big team working, and a large portion of their team, including the founder, the founders, were behind Neopets. Actually super smart people, like this guy, he had 1% of all internet advertising from his dorm room, went on from that to do Neopets, and then after that other games, and then he got into a big early person in behind the scenes in Ethereum and Ethereum DeFi. I'm super excited because I feel like if they can finish that game, it'll probably be the biggest game on Web3. It'll be huge. So I just hope they finish it because I've looked at it and what I've seen is super exciting. What else? But there's lots of people trying to do it. I was like, was it Cubetopia again? Like it's a project that's going to take a long time, but they built like a kind of Minecraft-like world which loads straight into the browser, and it's incredible. It will load into the browser on a desktop in like a few seconds. So that's what I'd like to see.
Yeah, absolutely. Thank you very much for your time. It's been a pleasure to talk to you. And I wanted to do a longer interview one day at the Dfinity headquarters in Zurich, if you're available. And
sure.
It's been a pleasure talking to you, and it's been a blast
Thanks,
here. Thank you very much.
Yeah.
Thank you. Bye-bye.